When we talk about nodes, student, if you will see, node is of two types. Just now I had explained you. One is radial node, and this radial node is also called as nodal surface. Let us write this as nodal surface. This nodal surface or radial node depends upon distance. And another type of node in the orbital is what angular node, or it is also called as planar node, or also you can say it is nodal plane. So there are different names that we are using. Radial node is called nodal surface and angular node is called as nodal plane. So for various orbital, if you will see, angular node that depends on the shape of the orbital. If you will see this, suppose if this is the plane, let's say if this is the nodal plane. So please remember, if there is a node or nodal plane present in any orbital, so electron density onto that plane will be what? 0. So if this nodal plane is present in xz plane, so electron density into the xz plane will be what? It will be 0. So electron density is above this plane and below this plane. Can you see? This is indicating density of electron above the plane and below the plane. So this plane, if you will see, that lies in xz. So the electron density is not present into xz plane. So this electron density is present to this orbital, this axis. So it is referred as py orbital because the shape of this orbital is what? Dumbbell shape. Can you check this? Density of electron is what? Dumbbell shape. And this is on y-axis. How we came to know about y-axis? Because the nodal planes are present onto what? xz. So orbital will be onto, electron density will be onto what? py. You got this? So if we have to find electron density if the nodal plane is given, then the trick is, if you will see, if it is written xz, so y is not mentioned. So definitely the orbital will be onto py. Similarly, you can find out for px and pz orbital. So when we talk about nodal plane, so please remember the plane is passing between the lobes of py orbitals. Can you see? These shaded region is what? Lobe of the p orbital, and this is the plane which is passing between two lobes. So between lobes of py orbital, where probability of finding of electron is what? 0. For s orbital, student, if you will see, let's take for first py orbital. If you see py orbital, the nodal plane is present in xz. Now we know that p subshell is consisting of 3 orbital. For px, if you will see, if it is px, so nodal plane is present into what? yz. And if it is pz orbital, then the nodal plane is present in what? xy. So what is the trick to find out? I told you, if it is xz given, nodal plane is present in xz plane, then which axis is not mentioned? So that will be the electron density, that is the orbital. If the nodal plane is this yz or yz, then x axis is not mentioned, then the nodal plane, if it is present in yz axis, then the orbital or electron density will be onto this axis. Similarly, in case of xy, please check that which is not mentioned, the z is not mentioned. So if the nodal plane is present in xy, then the orbital will be onto what? Ez. So I was talking about p orbital. In case of s orbital, student, there is no nodal plane because nodal plane depends upon azimuthal quantum number, that is L, and for all s orbital the value of L is 1 and that is expressed as what? 0. Now let us try it for d orbital. Now we know that d orbital the L value for d orbital, that is azimuthal quantum number for d orbital, is 2. So the number of nodal plane each d orbital is what, 2. Now d orbital have double shape, student, if you'll see this. And since L is equal to 2, so it should have 2 nodal plane. So we have to visualize the 3-dimensional structure. If you will see some orbitals of d, if you'll see the electron cloud is taking what? This electron density taking the shape of what? It is double shape. And the very important point, if you note, this density of electron is lying in between the axes. So let's say if it is dxy orbital. So for each d orbital, I told you there are how many nodal plane? 2 nodal plane. So the question is that for dxy orbital, there will be how many nodal plane? The answer will be 2. If it is dxy, so you have to check which axis is not mentioned. Yes, it is z. So there will be 2 nodal plane, and one will be present in xz and one will be present in yz. You got this? If it is dyz orbital, please check that which axis is not mentioned. X is not mentioned. So there will be 2 nodal plane. One will be on xy and one will be on xz. If it is dxz orbital, then which axis is not mentioned? I think it is y. So there will be 2 nodal plane. One will be on xy and one will be on yz. So if you will check, student, dxy, dyz and dxz, if you will see these orbitals, then the density of electron is lying in between the axes. So out of 5, there are 3 orbitals in the d subshell whose electron density is lying in between the axes. For dxy, yz, xz nodal plane are combination of the remaining axis with the axis of the orbital. Let's see this orbital. Again, this is double shape. And this type of d orbital, if you'll see, it is referred as dx2y2 orbital or dx square y square orbital. Now, if you'll check, student, here the electron density, the shape of the electron density is double, and this electron density is lying on to the axis. Can you see? Before this, when I was talking about d orbital, that is dxy, yz, xz, the electron density was in between the axis, but here if you'll see, the electron density is on to the axis. Again, this should contain how many nodal plane first? Any d orbital should contain how many nodal plane? It should contain 2 nodal plane. You can check that. Here the density of electron is higher onto x and y axis. That's why we write for dx square y square orbital. Can you see, this is the first nodal plane and this is the second nodal plane. So this nodal plane is passing through the lobes, between the lobes of the d orbital. So on counting, nodal plane 1 and nodal plane 2. So there are 2 nodal planes. In this case, dz square, this type of d orbital is having donut shape. It's donut shape, can you see? The electron density is highly concentrated onto z axis and there is ring shape electron cloud in between the lobe of the orbital. In this case, again there is 2 nodal plane because L value is 2 for all d orbital. But here if you will see, instead of nodal plane, we use the word nodal cone. So at this area, the electron density will be what? 0. So there are how many nodal cone? There will be 2 nodal cone. So out of this 5 orbital, the 2 orbitals are lying along the axis and 3 orbitals are lying in between the axis. Again, 2 nodal planes or 2 nodal cone for dz square. So again, let us revise the formula. If I have to find angular node, the value is what? L. The value is what? L. And radial node is what? N minus L minus 1. I repeat, angular node is L and radial node is n minus L minus 1. Total number of node, if you'll see, it is n minus L minus 1 plus L. So this L and L will get cancelled and the formula is what? N minus 1. For example, if you have to calculate total number of nodes in 3D orbital. So, is it possible for you to calculate? Let us try it. For 3D orbital, angular node value is taken by L. So, for L, if you will see, L value for D is what? 2. The radial node is n minus L minus 1. What is n? Here 3D. This 3 is indicating n number. So 3 minus 2 minus 1, it is 0. So total number of nodes will be what? 2 plus 0. This is what? 2. There are 2